Today, we're going to look at how to interpret weather and climate data. Now, we're going to start with climate graphs. Now, these show the mean monthly temperature and precipitation rates over usually 30 years. Now, these can be local, national, or global, and the precipitation is always shown as a bar graph and the temperature as a line graph. So in this example, you can see the blue bar graph for the precipitation and the red line graph for the temperature. Here, temperature is measured in degrees Celsius as well as degrees Fahrenheit, and then the precipitation is measured in millimeters as well as inches. Now, when we read a weather or climate graph, we need to firstly describe the overall shape of the graph. So here we can see that for precipitation, it's low for the first 3 months, then it steeply increases to a maximum in June, and then starts decreasing steeply, and then the last 3 months are low again. We then look for extremes as well, and also anomalies. Now, for the precipitation, there's no anomalies, and neither for the temperature, as we can see. As precipitation increases, temperature decreases, and vice versa. We can also name the seasons when we're describing our graphs. So with this one, we can see that in winter, because I'm not sure on which side of the equator this is on, so let's assume it's South Africa. Then we can say in winter it has the highest amount of precipitation, and I'm assuming this is winter because these have the lowest temperature readings. And then we can say that in summer and spring, precipitation decreases and temperatures increases. After this, we can also calculate the temperature range, and we can do this by subtracting the lowest number from the highest. We can also add monthly rainfall totals to calculate the annual rainfall, and we can divide this by 12 to find the average monthly rainfall. The next graph that we're going to look at is dispersion graphs. Dispersion graphs are useful for comparing sets of data. They also illustrate whether the data forms group or is dispersed and spread. So in this example, we can see that the grouped data is kind of represented as a tiny bar graph, and then the extremes or anomalies are dots either above or below this graph. Now, the values in a dispersion graph are shown on the vertical axis, also be used to represent the upper and the lower values along with the mean, median, and mode, and the extreme values. So here, this would be the maximum, this would be the minimum, this would be the median. Now, when we read a dispersion graph, we first need to read the title to see what the graph is showing. So this graph shows the rainfall dispersion between 1901 and 2018 in the northern Sikkim. We then need to read and understand what each axis represent. Now here my y-axis is the rainfall in millimeters and my x-axis is the months. Then we can describe the overall pattern of the graph. The overall in January, February, March, it has very low rainfall. It then steeply increases with the maximum amount of rainfall in July, and then decreases back with November and December having little rainfall again. We can then also identify anomalies, and these would be the tiny dots that are very out of sync. So especially October, the highest amount being 500 millimeters, that is definitely an anomaly, as well as September at 800 millimeters and July at 1000 millimeters. We can then complete any statistical analysis, like we can calculate the mean, the median, and the range for any of these data points. We then have a windrows. Now, firstly, the direction of the wind for a specific place is shown on the windrows. So if we look at the biggest bar here being south, it means the wind's coming from the south, not going towards the south. The windrose is made up of circles that radiate rectangles representing points of a compass. The rectangle's length will show how many days or times the wind blew in that direction. And in the center of the rose, display the number of days or hours with no wind. So for this one, 3.6% of the days had no wind. We can also see that there's different colored bars, and this gives us the different speed of wind. So where blue is calm, and then light lime green is up to 15.5 meters per second of wind. Then we have wind barbs. These are shown on a weather map to indicate the direction and strength of wind. Now, barbs point to the direction the wind is traveling from. So this wind in this example is traveling from northwest. The tip of the arrow shows the direction. Like I said, northwest. Now there's a combination of different symbols that show the overall speed of the wind and from where it originated from. Here we can see the different symbols. So a circle would be very calm, where half a bob is 5 knots. A full bob would be 10 knots. A full bob with 2 extra lines would be 25 knots. And a flag bob is 50 knots. Now we also get a double flag bob, which is 100 knots, and we also get a double flag with 3 full bobs with a half bob, and this is 135 knots. Now these type of wind direction indicators are mostly used in aviation. We then get isoline and choropleth maps. Now isoline refers to maps without color and choropleth with color. There's 3 types. So we're going to start with the first type, which is a isoheats. Now these are lines joining places with the same amount of rainfall. Now this example that I'm showing you is an example of a choropleth map. We can see here that orange parts would have the least amount of rainfall, yellow a bit more, green more, up to dark blue having the most amount of rainfall, up to 2,000 millimeters of rainfall. The second type is isotherms. Now these join places with the same temperature. And again, I have an example of a choropleth map, meaning it shows color. Now this map that from CSIR that I'm showing you actually shows you the temperatures of roads, where red would actually be some of the highest temperatures on roads. We can see as we get closer to the coast, the temperature of roads decrease. Lastly, we have isobars, and these join places with the same pressure. Now this map, we can see that the high pressure zones as well as the low pressure zones are also indicated. We can see that there's not a lot of difference in pressure over South Africa itself, but within the ocean there's a lot. Now each line is connected to a little number showing the pressure of that region. Lastly, for today, we have synoptic charts. Now these are made from meteorological station readings that are plotted to create this synoptic chart. These charts can sometimes show wind speed, wind direction, pressure patterns, weather fronts, cloud cover, and even temperature. So on the map that I'm showing you here, we can see that we have direction, right? It shows us the wind movement as well. It shows us the different pressure. So we have our isobars. This specific one does not show temperature, and this one also does not show cloud cover.